Good afternoon to all. We are going to have a brief discussion on glass ionomer cement. And glass ionomer cement means here what happens is like we have the contents which we are going to discuss are introduction, definition, classification, composition, setting reaction, properties, manipulation, and clinical consideration. Now, glass ionomer has got different synonyms. Synonyms are they're called as ASPA, ASPA, aluminosilicate polyacrylic acid. It is otherwise called as man-made dentin, polyalkylates, dentin substitute. These are the few synonyms of glass ionomer cement. This has been introduced by glass ionomer cement has been introduced in 1972 by Wilson and Kent. Since that time, many studies have been published in their clinical application. McLean and Wilson also in 1972, Simmons also in modifications are done in 1985. Now, the clinical development and the use of glass ionomer cements were first described by McLean and Wilson. And here, the release of fluoride ions was reported by Forston in 1977 and may help to prevent the recurrent case. Now, as such, say for example, in glass ionomer cements, we have the definition as such it is called as glass ionomer is a generic name of a group of material that use silicate glass powder and aqueous solution of polyacrylic acid. That is by Kenneth J. Anusaris. Then glass ionomer is a basic glass and an acidic polymer which sets by an acid-base reaction between these compounds. That has been explained by Nicholson and Wilson in 1994. Now, let us go to the classification. We have different classification by Skinner's, classification by McLean and Wilson, and according to Studieman, and also according to the intended application in different regions. So, according to Skinner's, there are three classifications. That is type 1, type 2, and type 3. Type 1 is luting. Here, the type 1 is luting. Type 2 is restorative, and type 3 is liner and basis. According to McLean and Wilson, type 1 is luting again. Type 2 is restorative. In that, you have two restorative aesthetic and restorative reinforced. And type 3 is lining cements and bases. According to Studieman, it is classified as traditional or conventional. Number 2, metal modified GIC, that is either can be cermet and or Baracle mix. Number 3 is light cured GIC. Number 4, you have hybrid resin modified GIC. And number 5, polyacid modified resin composite or combo. Then according to the intended applications, we have 9 types are there. In 9 types, type 1 is for luting, type 2 is for restorative, type 3 is fast setting lining, type 4 is fissure sealants, type 5 is orthodontic cements, type 6 is core buildup material, type 7 is high fluoride releasing command set GIC, type 8 is GIC for atraumatic restorative treatment, which is R, and type 9 for geriatric and pediatric GIC. So these finishes the classification of GIC. So we explained 4 classification according to the Skinner's, according to McLean and Wilson, according to Studieman, and according to the intended applications. The next thing, it goes with the composition. Composition, we have a powder and a liquid. The powder part is is glass. This is an acid soluble calcium fluoroaluminosilicate glass. This is how this calcium fluoroaluminosilicate glass is. It is formed by fusing silica, alumina, calcium fluoride, metal oxides, and metal phosphates heated at 1100 degrees centigrade to 1500 degrees centigrade temperature. And this glass is crushed, milled, and then ground into fine powder. So these ingredients, that is silica, alumina, aluminum fluoride, calcium fluoride, sodium fluoride, aluminum phosphate, zirconium oxide, lanthanum, strontium, barium, zinc oxide, etc. All these have different functions. So for example, silica, the main function of silica is a glass matrix and it increases the translucency. Whereas alumina is act as a basic fillers and it gives the opacity. Aluminum fluoride, calcium fluoride, and sodium fluoride acts as flux. And aluminum phosphate acts as a glass modifier and it improves the properties. Zirconium oxide increases the final strength, and lanthanum, strontium, barium, and zinc oxide, etc., it imparts the radiopacity. So when you said about the powder, the liquid part is typically the aqueous solution of polyacrylic acid in a concentration about 50%. Now, acrylic acid was also copolymerized with other acids like taconic, maleic, and tricarboxylic acid to stabilize that liquid. So this is the main solution is polyacrylic acid, and it is copolymerized with taconic, maleic, and tricarboxylic acid. And what are the use of this copolymers? That is, copolymers decreases the viscosity of liquid and it reduces the tendency for gelation and thus improving the storage and increases the reactivity of liquid. Then the role of tartaric acid in this GIC is tartaric acid will control the rate additive, it improves the handling characteristics, it increases the working time, it shortens the setting time, and it also prevents the premature formation of calcium polyacrylate chains. Now, we discuss another thing called as, and what is called as anhydrous cement. So here what happens is anhydrous cement, it's like the other one we said it is a powder and liquid, you mix it together. There the powder part is, I said, mentioned before, and the liquid part is also mentioned before. And after that, what do you call as anhydrous? Here the liquid, what we said before, the polyacrylic acid is the liquid and it is copolymerized by different other acids also, itaconic, maleic, tricarboxylic acid. And so here, what do you mean by anhydrous cement is, here the liquid part, which is the polyacrylic acid, is vacuum dried and incorporated with the glass powder. How that is vacuum dried? The liquid is freezed and powdered, and that powder is added into the powder which is already present as a cement, and there water is the medium to mix it. So we use water and the other part, already noted powder, which is the polyacrylic acid and the glass powder, which is together, and here we use normal water to add to the powder and mix it as a cement. So that is what is called as anhydrous cement. The setting reaction, we have three stages. One is an initial setting, final setting, and the maturation of the structure of a set cement. The initial setting will happen in the first 4 to 10 minutes from the start of mixing. There it forms the calcium cross-linking, and the final setting there will be an aluminum cross-linking also will be done. So calcium cross-linking which will happen in the first 4 to 10 minutes, and the final setting aluminum cross-linking will happen. But after that also the setting continues, and that is the agglomeration of unreacted glass particle surrounded by silica gel embedded in an amorphous matrix of hydrated calcium and aluminum polysols. That is how the maturation and the structure of set cement. Now here, very important thing is what is the role of fluoride in glass anomaly? Well, here what happens is the fluoride will lower the glass fusion temperature, and the second point is improve the handling property, strength and translucency. The fluoride release, what happens is short term it will be initial high fluoride release, long term it is low fluoride release, and the fluoride uptake is by the fluoride reservoir and the degree of the maturation and strengthening of the surface. Now, the adhesion is, it's a self-etching agent. Yeah, you call it as, it's a chemical bond actually. So acid, here the acid is self-etching agent. Hydrogen ions buffered by phosphate ion. The pH rises. Calcium ions takes up by carboxylic acid, and the layer of calcium phosphate polyalkylate complex is formed, and there will be a firmly bound to enamel and to dentin, and the polyacid chains bound to replicated layer on the reprecipitated layer of the tooth surface. So while before you are doing the glass ionomer, mixed glass ionomer on your teeth apply, we do a self-conditioning. What do you mean by self-conditioning? Self-conditioning is a pre-treatment of the surface to eliminate the wide variations found in the structure of the tooth surface following the tooth preparation. You understand? Once again, I repeat, surface conditioning, it is the pre-treatment of the surface. It is the pre-treatment of the surface to eliminate the wide variations found in the structure of the tooth surfaces followed by the tooth preparation. Now, what are the different types of surface conditioners which are used? The basic thing is polyacrylic acid. That is 10% polyacrylic acid for 10 seconds. It removes the surface debris and smoothens out the irregularities. It tends to open up the dentinal tubules, and it is also a conditioner of choice as a part of the cement forming system. Now let us go to the mechanical properties. The mechanical properties we call it as compressive strength, tensile strength, hardening, solubility and disintegration, etc. The compressive strength of GIC is 150 megapascal. The tensile strength is 6.6 megapascal. The hardness is 48 kHn. Solubility and disintegration is 0.4. Next property is aesthetics. Coming to the aesthetic property, a glass ionomer is an excellent aesthetic film material because it has the degree of translucency which arises because the filler is a glass. The color of glass ionomer remains unaffected by the oral fluid as compared to composites which tend to stay. Translucency increases as the age is reflected by a decrease in the opacity. The next property is dimensional stability. The correctly manipulated and protected glass ionomer material shows a volumetric setting contraction of an approximately 3%, which develops slowly through the setting process. Now, the next thing which I thought I would discuss is about the dispensing and mixing. Glass ionomers are available in 3 forms. The one is powder and liquid, which is separately for hand mixing. Then for mechanical mixing, we have glass ionomer capsules are available. And the third type is twin syringe for a mechanical mixing. So for hand mixing, we have a powder and liquid. For mechanical mixing, we have capsules and twin syringe. So these are the methods which is available. How do you manipulate the GIC? Manipulation of GIC: dispense both powder and liquid carefully. Divide the powder into two equal parts and prepare to mix. Incorporate the first half of powder within 5 to 15 seconds, rolling the powder into the liquid without separating the mix over the slab. And do not spatulate too much. Rest of the powder then quickly added and mixed by folding the mix on itself until a uniform glossy appearance is achieved. The mixing time should not exceed more than 45 minutes. Manipulation considerations. Now, the manipulation considerations are: number one, surface of the prepared tooth must be clean and dry. Number two, consistency of the mixed cement must allow coating of the surface irregularities and complete the sealing of the process. In number three, the excess cement should be removed at appropriate time. Surface must be, next point is, surface must be finished without excessive drying. And the last point is protection of the restorative surface must be ensured to prevent the cracking dissolution. Now, there are few certain points which has to be noted while mixing and dispensing the GICR. The powder liquid ratio as recommended by the manufacturer should be followed. Number two, cool dry glass slab, a hyphen, we have retard the reaction and extend the working time. It will retard the reaction and extend the working time. Then comes the powder liquid, this powder to the liquid. Or say for example, the liquid is just dispensed before mixing only. You should not keep the liquid dispensed before itself. While you are mixing with the powder, you can dispense the liquid. And next point to be noted is powder incorporated rapidly to the liquid using a stiff spatula for a restorative application and a metal or plastic spatula for luting. And the mix should have a glossy appearance and inadequate free acid for bonding. So to have a dull appearance, there will be inadequate free acid for bonding. What are the clinical considerations? In clinical consideration, we have 6 points. That is, one is non-carious lesion. Number two, non-carious lesion means no mechanical preparation except at margins. Then the second point is the tooth surface should be cleaned with slurry of pumice with water. Number three, the rinsed with water, dried and conditioned. Number four, the point is washed with air, water spray for 10 seconds and dried lightly. Material carried to tooth with the help of plastic instrument. Material carried to the tooth with the help of plastic instrument. Contoured matrix is used to cover the GIC. Once that the matrix is removed and cement is protected by Vaseline or petroleum jelly or copal varnish. Now, the next point is early finishing of restoration should be restricted to removal of gross excess alone. Sharp blade hand instrument should only be used. Surface should again be protected using a lubricant. Final finishing and polishing done after 24 hours only. To ensure the success use of GIC, there are 3 parameters that must be controlled. One is conditioning of the tooth surface. Number 2, proper manipulation. And the third one is protection of cement during setting. These are some few photos. Glass anomalous indication, class 3 restoration, erosion and abrasion lesions. Then the third one is primary teeth restorations, class 5 caries lesions, pit and fissure, etc. Then comes then for it's used for luting of restoration, bracket bonding, minimal cavity preparation for window. Glass ionomer as a liner and a base. It is very useful as a liner base. It's also you can do a sandwich technique also. Glass ionomer cements in endodontics. That is one is what is the role of glass ionomer cement in endodontics? That is the first one is root canal sealing. It is used in root canal sealing. It is used in retrograde root canal filling. It is used in perforation repair. It is used in the treatment of vertical fractures. It is used in the treatment of coronal sealing after no root canal treatment, after root canal treatment, coronal sealing after root canal treatment. And what are the contraindications? Contraindications are class 4 lesions or fractured incisors, lesions involving large areas of labial enamel where aesthetics is of major importance, and class 2 caries lesions where conventional cavities are prepared, replaced of existing amalgam restoration, and lost tooth cusp areas. So thank you. By this, I thought I'll just brief you about the glass ionomer. And we will be continuing with the modification of glass ionomer cements in the next session.